Righty, well, I think we can go ahead and get started here. So welcome everyone to the Tulsa.net user group. Sean, the normal host, is having some technical difficulties. He'll be joining back up a little bit later. So I'm the speaker for this evening. My name is Mitch Sellers. I run a software consulting business here in the Des Moines, Iowa area. Work with .NET Technologies primarily, 17-year Microsoft MVP. And excited to be here with you guys tonight to kind of talk about all things Web API documentation, OpenAPI, Swagger, and the like. So we'll dive right in here. We are virtual here as well, but please do feel free to come off of mute, make a comment, in the comment section if you've got questions along the way. This is a talk that, I can get through the content fairly quick, but sometimes it comes down to specific questions, things that you want to see, things that are hardships in your organization or otherwise. So please do feel free to get my attention at any point in time, and I'll make sure to stop at a couple of strategic points here. Again, just a little bit about me. My contact information is up here. I'll gladly put this up again later or drop it into chat if need be. The biggest thing to note, github.com/MitchellSellers. That is where the demo repository is for what I'm showing you folks tonight. So the way that I've set up the code samples that I have for this evening, there are successive commits throughout that process that are basically allowing you to kind of see what steps happen. So when I do file a new project, I have that saved as an individual commit. When we go and do some of the initial setup configs, that's another commit. So you can see the diffs between what was done from one stage to the other. It'll really help. It should help you with your own projects if you maybe are in a different state of compliance or ability to bring things together to help implement them within your own solutions. That way you can kind of take a look at it. You don't have to go digging through like, okay, what was that documentation? Where did I find it? And everything along the way. So, and you'll see me work through that process tonight as I kind of work through the code demos. It also helps so that then I don't have to try to type while you all watch me, because it doesn't always go as well as planned. So just keep that information in mind along the way. So the idea here, you're trying to keep it to basically, a 50-ish minute presentation. I know we are, in your evening. So from a slides perspective, I want to be quick here. The real purpose of even throwing some slides before this is to talk about what we're trying to accomplish with API documentation. Why do we need it? Who are we trying to solve? And then really talking a little bit about the options for hosting so that we kind of understand where might things go. Because when we look at the samples, the documentation, Microsoft as examples, there's a couple of loose ends that get left there. And a lot of people ask, well why? What kinds of considerations do we need to have with that? So the idea is to clear up a little bit of that. And then really most importantly, though, we want to get into the code demos and really take a look at how do we go from an out-of-the-box configuration that maybe doesn't have the greatest amount of detail to, a real-world scenario where we're actually publishing information that is valuable to those that are using your APIs, but doesn't have a huge burden on you to make sure that you're getting things done correctly. So the sample project, again, I got the whole link here. It's just a lot easier. Go to github.com/MitchellSellers. It's the only one out there that's ASP.NET Core API documentation. Really easy to find. I think it's the second or third one in the repo list. So why do we need API documentation? What are we trying to do? Why is this something that is so important for development teams? Well, we know that APIs are great, right? Somebody else did the work, let me leverage it. Somebody else has a system, let me call it. The thing is that we also know that documentation is one of those burdens that developers just hate. I am sure that every single one of you at one point in time has said, I'll come back and document that later. And I'm fairly confident that most of you did not, in fact, go back and document it later. And that's exactly where I see API documentation amongst teams, is if it looks as it's a burden, it's something that gets pushed back. It's something that's like, oh, we'll get to it. Or, oh, we'll let the training team handle that. Or, okay, we can do this elsewhere. And then you get a lot of extra pieces. So why not take a look at the tools that are out there and what's available for us? Because the reality is that ASP.NET allows us to do about 95% of the documentation directly in your code with standards that you're already using, that are already part of references that exist in your projects today. You just have to know enough to add the right attributes, the right metadata, the right comment structure to be able to then get that information, expose it out, and consume it elsewhere within your projects. And so the whole purpose here is really to make sure that you are aware that we don't have to do a lot of things. It's not a Herculean effort. It's not managing a separate set of documentation. It's not pushing things through another system. It's not spending thousands of dollars a month to do Azure API management. You can do that if you want. It's kind of a cool product, but it's really, really expensive, right? So let's look at the tools. Let's look at the ways that we can do things out of the box. So what are we trying to do? When we look at our API documentation, it's really important for us to understand exactly what we're trying to do. And when we look at the tools that are available, and we're going to talk about two of them this evening, there's really kind of three overall ways that you could look at documentation. It's read-only documentation. We just want to show people, hey, make a get to this. Here's what the JSON looks like. Good luck, have at it. We also could be, hey, here's our API structure. You got to do it all on your own. But you know what? Here's a good example. Here's a sample piece of data. Here's all of the validation requirements of the fields and the data that we're sending you, but it's still a read-only. And then we could go for, the Cadillac version. We could go for something to be able to give people a try now button. If you have an API key, let them drop their API key in and actually hit the API. It's kind of cool, right? It can prove that your API works. Maybe they weren't smart enough to make the proper request. Maybe they didn't JSON format it properly, but you can showcase, hey, my API is live. So we want to understand kind of where we're going, and I'll talk through as we go through the progression this evening of the tools that are out there, how we can kind of meet each of these respective goals along the way. And to do this, right, there are two different tools that we're going to talk about tonight, and Swagger UI is the first one. So Swagger UI is a third-party library that you can bring in. It's open source. It was the gold standard in all things Microsoft leading up to the .NET 9 release. I'll talk a little bit more about how things changed with .NET 9 in just the next slide here. But the idea is the Swagger UI can do all of the above. It can create read-only documentation. It can give you detailed examples. You can give it a try now experience and let people actually interact with your API. So we can do all of this single line of code, really, easy to get some of that stuff going. There's another tool that's been recommended by Microsoft as part of the official Microsoft documentation called ReDoc. Now, the biggest thing is it's really only for the read-only stuff. There's no try now behaviors. And the fundamental difference is the look and feel. Swagger has one look and feel, ReDoc has another, and they're vastly different, even though they're taken from the exact same pieces of information and the exact same data sources. So when we go through here, these are going to be the two that we're talking about. I think it's worth, it's important to understand here that there are others that are available, right, depending on what you want to do. And so some of the things that we're looking at here will also take that into consideration. So we are using OpenAPI generation out of .NET, and then we're combining some other pieces of information with it in the end to generate stuff to work with Swagger. Other documentation engines can also read an OpenAPI spec, and they can do things. So you can do kind of whatever you want with those other tools outside of the scope, kind of what we're going to talk about today. We also have to take a look at where do we host our API documentation. So the examples I'm going to be showing you tonight are hosted internally to the application. So your application will have a new endpoint. You'll be able to go to the documentation. It's going to be there. There are third-party solutions that can host, consume, and display these things. They have costs associated with them. They have all kinds of crazy things that you can do, right? Metrics, analytics, and data. So if you're looking to go somewhere, it's important that, that's something that you can take a look at, but you can host locally. There's not necessarily anything wrong, but we have to understand the security implications of what we're doing, right? If we have a try now option and it's in our production environment and we have our production APIs out there and we have an API that doesn't respect security, well, we just made a malicious actor's life a heck of a lot easier, right? They don't even have to go out to the command line. They don't have to create their own web request, right? They have the tool. So when you go and look at this, it's a little bit outside of the scope of what we're going to talk about today from some of the security perspectives. We're going to talk through some of those things. We're going to take a look at, some of the things that are there from the Microsoft samples and what Microsoft says, hey, start here and work forward. Now, it's important to realize, especially if we go look at ReDoc, if you follow Microsoft's documentation or you follow ReDoc's documentation, you might get led to, well, ReDoc is a paid service. ReDoc is I can only do it if it's ReDoc hosted and everything else. There are two variants of ReDoc. We are looking at the free open source version that you can run on your machine. There is a paid version that is something that you would need to look at on your own. So it's just really good to set up that boundary, set that expectation of where and what we might have available to you before we get into the really detailed examples. So where do we go? Why can't we just, why doesn't Microsoft just give us a great example out of the box? Why don't we have something from Microsoft that gives us, everything that we need to, do everything? Well, what's really interesting, the concept with the baseline configurations. They used to, prior to .NET 9, set most of this stuff up for you, and you just had to uncomment a couple of things. Starting with .NET 9, there was a little bit of a fallout of the Swagger UI group and Microsoft's want to include things into the project. So now it's a little bit of a further gap. But when you go out to the Microsoft documentation, it just tells you how to do it the way that used to be in the project template. So the baseline configuration gets you there. The thing is that they don't really get all of the information out there of how you are able to get things going. And I do see kind of two questions in chat talking about OpenAI, Swagger, and how they're different. And we'll get to that in just a couple of minutes because it's a little bit easier to explain when we look at the API endpoints and how things are kind of pulled together. So what we're focusing on this evening is to really try to get those gaps filled. Try to figure out how do we provide more information with our code to actually give the OpenAI documentation, the Swagger documentation, the right information. And we're focusing on things like descriptions, validations, response types, and error descriptions. Being able to give our users not only, hey, this is a method that does this, but it is of this data type. It has these required fields. It has these examples. It has these response types, and each of these response types has a different structure. And that structure for this response type is X. And error descriptions to say, hey, if you get this error code, here's where you went wrong, rather than them having to guess what they might have done wrong. And so that's where we're trying to really push things to the point of here's where you put together the real world example versus the Microsoft documentation that goes on for 23 pages that says, well, you could do this, or you could do that, or you could do this along the way. So that's really what we're trying to work through on our side. So when we look at our code sample here, how do we get started? Where's the best place to go? If you're wanting to compare this, go back and look at this on your own. The best way to get started is to create a new project using the ASP.NET Core Web API template, and be sure to check the box for Enable OpenAPI support. If you have an existing project, you can use that template as an example of how to get there. And then with .NET 9, we stop there. That's all you get. You don't get any more information. You don't actually get a human-friendly display of any documentation in your project when you do that, when you check those boxes. If you created your project in .NET 8 or earlier, you got a lot more information in there. So as we talk through some of these examples, I'll try to call out some of the things that may exist in your project. So what are our options? How are we going to make this whole process work? Well, there's a product, the open source project for Swagger UI, and the Swashbuckle ReDoc is under the common name of Swashbuckle. This has been the gold standard for many years in documentation. It was in the Microsoft templates. The release notes for .NET 9's release said, and I quote, that there was a lack of support for Swashbuckle, so they removed the project. There was a period of time where there weren't any releases of Swashbuckle in about 6 months. It's a documentation engine. The documentation spec hadn't really changed a ton, but there were some bugs that were piling out there. Approximately a week and a half after that announcement was made, all of a sudden, bam, there was a whole bunch of releases with Swashbuckle. New releases of the main items, a release of Swagger UI, a release of ReDoc UI, and there's been consistent maintenance and everything going forward. What's really funny is if you go out and look at Microsoft's documentation for how do I document a web API project, guess what it tells you to use? Yeah, the thing that they removed. So as much as they tried to say, hey, we don't want to do this, I think some of it is they just didn't want to include that third-party library by default. But then when you stumble across the docs and you bring it in, now it's on you. But it's definitely a very interesting piece of history around how this comes together and what that structure looks like. So from my perspective, the project has been supported. They're active development in the community, but it is a third-party dependency that drives some of this. And so as we get through those boundaries, we'll start talking through what that means and what that looks like along the way. So without further ado, let's get into the source code examples, because I think everything will start to make a little bit more sense when we start looking at exactly what we get with an out-of-the-box Visual Studio project that was set up for WebAPI. So I'm going to kind of move things around here. I'll also zoom in a little bit because I know that at times and places things are a little bit more complicated for folks to be able to see. So when I look at a default project setup in Visual Studio for a WebAPI project, this is what you get in your program CS. So we can see in here that we have our standard call to controllers. We then have a builder services add OpenAPI. So that tells us, oh, hey, we want to add OpenAPI. What is OpenAPI? Well, OpenAPI is a process that goes out and explores all of the API controllers that you have. It creates a JSON document that describes those APIs. Okay? And in the traditional .NET Core, or .NET 9 setup, we add the services, and then down here is where we actually map the endpoint that we end up using to be able to interact with this. So the one note here is, oh, we're only doing this if it's in development. So this is one of the things that trips people up a lot when they use the default template. Everything's working great. You work on your local machine. All of the documentation is visible. You publish it out to your QA environment, and then nobody can access your documentation because people just very easily glaze over the fact that they copied in the, hey, this is a development environment. Okay, so now out of the box, we have map OpenAPI, which is going to serve up our OpenAPI documentation with a specific URL. Now, to be clear, the out-of-the-box project does not come with any great examples. This is the weather forecast controller, which is done with absolutely amazing coding standards. We have no XML comment documentation. We're not even using primary constructors. We have a really fun static read-only that gives us random weather, but it gives us an example of an API. If I run this project in the default configuration, the only thing I'm going to get that is at all visible from an API documentation perspective is that JSON file that is the OpenAPI spec. That JSON file looks like this. And in here, we have things like the OpenAPI version, the information about the project. The title ends up being the name of your project, a pipe character, the version. We have our servers. It's able to inspect, what URLs are we available. It has then our individual paths. Okay, /weather forecast, get, we have an operation, we have responses. But then notice in here that there is some really interesting data around our response types. Notice that our response type is like, hey, we can be plain text, we can be JSON, we could be text JSON. Well, this gets a little bit complicated because this isn't actually probably how my API is going to be implemented. So we have to start thinking about how are we going to give more information to OpenAPI to make this more valuable. But again, this isn't necessarily the most usable file, right? This is not human friendly. If somebody is using Postman or something else, they can import this file because the OpenAPI specification is something that is commonly supported by tools that are built for that purpose. But the idea here is we want to get more information in here, but we don't really want to have to do a ton of extra effort. So if we go back to our project here, I'm going to go ahead and stop debugging. And then I'm going to go forward here and I'm going to add Swagger UI to the project. So what we're going to do is we're going to add Swagger UI to the project. The first thing that we had to do to make that happen is we added a single NuGet package reference, swashbuckle.ASP.NET Core. That brings in the Swashbuckle project itself. And then we have two changes that we end up making to our project startup. So we have our Swagger UI implementation here, where the first step here is we're adding to our services the Swagger generator. The idea behind the Swagger generator is that it is going to generate API documentation in the Swagger format with this information. So I am saying that, hey, I'm using OpenAPI information. I'm using this version, this title, this description. Here's my terms of service. Here's my contact information. The other thing that I have is down here, I am including also an XML documentation file. So I'm using the assembly, get executing assembly name.xml, and then I'm saying, hey, Swagger, include the XML comments from the base directory for this documentation file. This process tells Swagger that we want to have it be able to generate our documentation for it. It is aware of OpenAPI, and it's going to consume the OpenAPI information as well and merge in its processes to help enrich our data even more. And then down here in our actual environment setup, we can do use Swagger. So this registers the service that actually creates the file with Swagger gen. And then we also add Swagger UI. This is going to now give us a friendly human look to our application. And we take two primary configurations into this. We have our Swagger endpoint that says, where do I grab my Swagger documentation? Because maybe I'm not even grabbing it from my same project, right? So, okay, I'm grabbing my Swagger JSON from this location, and then I have my route prefix. So this is where, again, where do I want this to go? If we go look at our weather forecast controller, I added just a couple of pieces of really basic documentation. I added a summary to my controller. I added a summary, some remarks with a little bit of extra detail, and a return on my get weather forecast method. If I run the project now, I'm going to find that I can now visit localhost/Swagger, and I have documentation available for my project. You can see here up at the top that we've got our configured information, the name of it, the version, the Swagger JSON URL so that we can go look at what the JSON is, our description, terms of use, website link, and then now we have our individual method information. In some ways, this looks great, right? Here's my summary that came out of my XML comment. These are my remarks. If you notice, it got really fancy formatting for me automatically because I had, the method name with a path. So that helps me kind of do things. I've got a try it out button over here so I can actually try out this API. And then down here, I have my responses. And this is where the documentation is still a little bit sketchy because I still have those 3 response types: text plain, application JSON, text JSON. So we come down here, you'll see here also, I have some example values. It just put in today's date randomly, a temperature of 0 Celsius and Fahrenheit. Now notice, a smart individual that's looking for something is like, well, okay, I understand you're giving me schema, but you're not going to have the same value, and get some little bit of confusion along the way. And we'll try to make that a little bit better. And then under schema, you'll see that we have a little bit of a fun expandy collapse section here where I can get information about the schema. Okay, so the weather forecast has a date property that is a string representation of a date. A temperature Celsius that's an integer, a temperature Fahrenheit that's an integer, that's read-only, a summary that is nullable. So gives us some pretty good information. We can start to really actually build out an API if we want to, but when we go look at this, right, we don't have a lot of information. We might not be able to completely understand the business rules behind it or what kinds of applications, what the application is expecting us to do. So if we go back to our project, and we'll kind of see here, we can continue to add information. And notice that this description from the controller doesn't come in. Well, the reason why this doesn't come in is because in our program CS, when we add this XML comment, there is an optional parameter that says include controller XML comments. By default, it's set to false. I have no idea why the default is, hey, I want you to bring in all of my documentation, but ignore this. No idea why, but that is the default. And if you read the documentation, a lot of individuals end up missing that. So it's really important, right, to throw this in here. If you have a project where your models are in a different project, be sure to remember to register all of your XML comment files, not just the one that contains the APIs, because it needs those to be able to pull that information together. And one thing that people always ask as well is, well, when we do this, what does this look like? Does our OpenAPI document, does it change format when we do this? If you notice here, my OpenAPI document doesn't change at all. This is no different than what we were looking at before. The OpenAPI spec in current.NET does not enrich itself with those methods. That is where Swagger and Swagger's generation process is really valuable to you as a developer because it's meshing those pieces of information together. If we go look at our Swagger JSON, this is where you'll actually see that the other information is there. Now, funnily enough, what is your Swagger JSON? It is nothing more than a more built out OpenAPI specification. If you look at the roadmap in .NET 10, there is conversation about improving the support for OpenAPI generation with the out-of-the-box map OpenAPI. So I would not be surprised. I've not tested with preview releases of 10 yet, but I would not be surprised if we start seeing some of those things in here. But this is what Swagger Gen is doing for us. It is taking and letting us configure that top section. It's grabbing the summary, the description, it's grabbing some of the other pieces of information, out of that documentation and just simply manipulating that OpenAPI documentation to spit out a more complete OpenAPI doc. And then Swagger UI is the pretty part. If you are an Azure customer and you want to use the Azure API management product, guess what? You can take this and push it out there and it will do fancy, pretty things for you, but you've now given those descriptions, you've given some of that information. So we're looking pretty good, but there's a couple of things that I like to point out. Not everybody likes the way that Swagger UI looks. I think it's functional, but I really don't like the way it does dependencies and requirements and structures. So there's another option with the Swashbuckle project, and that is to include ReDoc. ReDoc is another package available. So we add a package reference to Swashbuckle ASP.NET Core ReDoc, and then we add one additional block statement to our project startup. Use Swagger UI. I could get rid of this if I didn't want the Swagger UI version, but now I want to say use ReDoc. My configuration, I set my route prefix, my document title. I have a small API, so I want to disable the search function. I want to hide the download button because I don't want people to download my JSON. Just showing you how you can configure some of the things that come out of this documentation. So now what we can do is run the project again, and we can do a side-by-side comparison of the Swagger UI, which we've already looked at, and we can look at ReDoc. Now, for those of you that have done a lot of API integrations, the structure of ReDoc looks a lot like you might see as some of the other APIs, that you've consumed. Like if you use the Stripe API, for example, the ReDoc style of a left-hand navigation menu, a center column where that's your documentation, and a right-hand column that are your requests. That is really the common pattern with ReDoc. And you'll notice a lot of people, their initial reaction is, well, there's so much wasted space. I can't necessarily disagree with you. You can introduce your own CSS. You can change styles, add colors, inject custom HTML into these processes to continue to style them along the way. But you'll see the same bits and pieces that we had with everything that we had from a Swashbuckle and Swagger perspective. We have our project name, we have our website link, we have our terms of use, we have our description. This is our controller name. This is our method name. Now this is interesting, right? It's not get weather forecast, it is my description. So the description comes over here, but then my method is over here. And then this is my description, that it does not provide any real value. And then this is our sample request. So as I go through and look at these items, you can see here that you can adjust, you can see the URL, you can see the content types. We still have this issue with multiple content types. But then down here, if we look at our data format, I'm just going to go ahead and change our response schema here to JSON. You can see here that it does a similar behavior, but it doesn't really give me much detail about, required fields, not required fields, those kinds of things. So same data, same structure, still consuming the Swashbuckle generated API documentation, but a completely different front-end look and feel to give a different user experience. There's no right or wrong. It's all about how your users consume it, how you build your API, and what we want to look like. So now that we have two examples, what I want to do is I want to jump forward a little bit and show you how can we make things a heck of a lot better. Well, what we can do is make things a lot nicer by adding some documentation to our project. The documentation we're adding here is all done and all supported by namespaces and attributes that are included by Microsoft. So one of the biggest questions I get from people is, well, am I going to be creating a dependency on Swashbuckle? Not exactly. You're only creating a dependency on Swashbuckle when you are generating the UI because of OpenAPI and the way that things are working. And so the idea here is that we're able to, give this metadata, and then eventually, right, Microsoft, when they get with the program, right, we're going to see the same thing work, hopefully out of the box with OpenAPI. So what I did here is I made some changes to the documentation for our weather forecast. So for our weather forecast, I just made a couple of really small changes here. We have our summary, our remarks, our returns, but notice that I have a produces response type and a response attribute, or a response element in my XML comment. These two pieces are directly linked together. Produces response type says, I am generating this response. And you can have multiples of these. So if you could generate a 200 and a 400 and a 401 or whatever the case may be, you can put each of those. The XML comment allows you to put the description as to what that method or what that response means. So you could say, you gave me bad data, so now you're getting this response. And that allows you to link those two pieces together. It'd be really cool, right, if we could do this inside of the attribute, but it's not allowed. And I don't really see that kind of coming at any time in the current future. But let's go look at a little bit more of a realistic scenario. And I created a sample controller for working with to-do items, just to kind of give you an idea of how you might do something in a real world application. So in this case, the controller that we have has a summary. It's marked as an API controller. It has a route definition, but I added a produces content type application JSON at the top of, on my controller. What this is going to do now is it's going to tell OpenAPI, no, don't assume that I can do plain text and I can do application JSON and I can do text JSON. I'm giving responses of application/JSON. What this does now is it's going to tighten up that user interface. It's going to change that drop-down list to now have a single selection. So then what I can do is I can go into my methods and be far more descriptive with those as well. So now I can create a method. I have my summary, I have my remarks, I have a parameter, I have a returns, and then I have my response codes. Oh, a 201 means it was created successfully. The ID of the newly created item is returned. A 400, it was an invalid. You're going to get your error message. A 409, item already exists. And then what we're able to do is down here with our produces response type, we are able to say that, okay, a 201 is this response type. A status code of bad request is going to give us a string response. A 409 conflict is going to give us a string response. And then in our code, you can see here that we have a bad request or conflict and a created response. We also then have an ability to, do a get, and that get has an ID parameter and things of that nature. So we also then have our create to-do request endpoint here, or method, and this basically allows us to define a required, a max length, required, etc. But there's one piece of really interesting things for those of you that might be using ReSharp or other tools. If you notice that I have an example included in here in my XML comment, but that example does not follow the same indentation and spacing formatting as I have with my summary comments. Notice that the example is all one line. And the reason for that is that the example, when it's submitted to the documentation, retains white space. So if you do a new line character, it's going to retain it in that example, so you had to keep it as one line. But the goal here is I can say, hey, here's a sample of what a title looks like. Here's a sample of what a description might look like. And what this does is allows you to then really push that limit and be able to get your users a bunch of really good detailed information um, along the way. So with these couple of small changes to the process, what I'm able to then do is have a far better user documentation experience. So now if I go and look at my Swagger documentation, you'll see that I have my to-do controller grouped together. I have my description. I have my post method of create. Here's how we do it. My description. I have no parameters. My request body, it knows application JSON. It's the only option available to me. Here is my example. Now this is a far better human readable example. Oh, finish API implementation. I really should make this and update this information. So now you can give your users context. Maybe you have something special with your sample values. Dates are a great example from an API perspective because everybody has their own little thoughts of what way that you might want to pass in a date, even though it should be standard, right? So we get that. We also have the ability to look at the schema, and the schema, when we look at the way that Swagger does it, we actually can see here that, okay, the title is a string with a max length of 100, a min length of 1, and here's my example. Description is a min length of 1, an example. What's interesting to me is when I've talked with developers, they get really confused of min length 1. I don't know why. I read min length 1 is I got to put a character in there, right? That's what I read it as. But they're like, well, I want it to say required. I don't want to say min length of 1. I want to say required. We can't really change the way that it renders, and that's where we'll start to see some differences between the way that we get things with Swagger UI versus ReDoc. And then we can see here that the due date is a string that is a date time representation, but it's a nullable representation. So it could be null. We come down here, now we have our responses. And again, we have a far nicer response for the individual. We show what we're actually returning. In our case, even though the media type is application JSON, right, we're returning a raw string. It actually lets us see that representation. But now we're able to put the individual descriptions in here of what happens when you get it. So a really good way to help, provide a much more usable response for the individuals that are working to, consume your application. So this gives us, kind of a fun way to do things, and we can actually use the try it out method, and you'll see here that, we can go ahead and make the request, and then it actually shows you the response that you get back from the API. And so it lets you see what came back, lets you see the response headers. So we can see here that it even proves that we did get, an empty response back. It was a 201 code. The date that we executed it was, 20 minutes after midnight, 11 seconds UTC, and the server was Kestrel. So you can see that we really were able to completely execute that. So kind of cool what we can do with the Swagger UI process. ReDoc gives us the same information, but it has a more polished or professional look, I think, in most people's eyes. The left-hand side here is a navigational tree. So now we see here, we have our to-do, controller, and then each of our methods, our individual items. And now we can see here that we have our controller, we have our description, we have our create method over here with a nice color visual that this is a post. A get is green, right? So you can see the difference. A delete is red. So they do a really good job of trying to give a little bit better visual. But what we see a lot of folks really liking is when it comes down into the request body and schema. Okay, we created to-do item. If this is our message, but then here's our request body schema. We're saying the same thing as what we said with Swagger, but they visualize it different. Title, required, red lettering, really clear. It's a string, 1 to 100 characters. Description, required, it's a string, non-empty, right? A little bit more succinct, a little bit more clear. I don't have to expand and collapse. I don't have to toggle between my example and my schema. So I get a little bit better visual as I'm trying to work through my process. We have our option on due date value here. We have our request samples. We then have our response samples, and they actually will show, what the different response types are. So if you have multiple response types, it will actually give you that information. And it also helps you out. 200 statuses, those are good things. So those are going to come out as green. 300 response statuses, like a redirect, those come out blue. And error responses, 400s and 500s, come back as red. And so again, we can take a look at all of that information. And again, center column section is human-friendly words, things, behaviors, items that we want to be aware of. Things on the right are the actual programmatic things that we're looking for. And so we can kind of see here, this is another, a get. This is the example then of the weather forecast, which is a little bit unchanged with just a little bit of extra detail. So the same metadata was used to build both of these interfaces. The key piece here comes down to, where do you want to go? And I think that Andrew's comment in the comments section is, I think, the number one thing here. It's what you like. It's what your habit is. It's what your audience is. And that's what's really powerful by using the OpenAPI standard and then using something like Swagger, or eventually, right, Microsoft's OpenAPI generator all on its own. You can then take this information and you can push it to whatever UI tool that you want. I personally am so used to Swagger because I've been using it for, I don't know, a decade at this point, that I just know where it is. The ReDoc side is much more familiar to the really fancy people. It looks more expensive. It looks more polished. It looks more refined. If you have a non-technical person, the documentation on the right side here looks, quote unquote, more professional, right? It looks like you spent a lot more time doing the documentation with the ReDoc style. But that is the kind of the key fun part here, is that's all it is it's how much polish does it do to what you're doing? Because here is the updated OpenAPI spec that Swagger built for you. It injected the summary, the description, the request body description. It has the content types. It creates the different references and things that are needed. And then as you get further down, you can see here's my responses. So here's my 201 in my description, my 400, my description, and my content structure, and all of these things. So all of this is coming because you're combining those two pieces of process together to be able to get to a true set of API documentation. And the nice thing is that, again, people are worried about, well, what if Swashbuckle goes away? What if Microsoft was right and, Swashbuckle goes completely away? Microsoft is continuing to move forward with their OpenAPI, right? The initial version of this document, because you'll see here, Microsoft brings some of it in, right? The Microsoft version, it brings in the method, it brings in the request body, it brings in the responses, and look at this, it even brings in the response and the response content types. But what it doesn't bring in is they don't bring in the XML comments, right? That's the real power that you're getting with Swagger. So when we look at the difference between what Swagger Gen gives you and what Microsoft gives you out of the box, that's your real value add right now. And then on top of that, you have your UI. But OpenAPI as the standard, this is the first part of that puzzle. The first part of the process is to get this information updated and correct. And so, when we look at, risk and relative, concern from an organization perspective over time, it's not a huge deal along the way. And, one of the things, in the comments here, and I think it's really worth noting, oh, please make sure your error messages are actually helpful. I had to deal with one the other day. It was the table structure didn't match the template when uploading a contact list to a bigger VoIP provider. What was really the issue is one record out of 868 had a null value, and the developers didn't give me any info. And that's the big thing for me, is if you set the standard that you always document, it makes it really easy. Now, let's fast forward to the really fun stuff. You all have existing projects out there, and you have probably not documented them to this level of standard with what you're doing today. My guess is that most of you probably never figured out that system or Microsoft.ASP.NET Core.MVC has the produces response type attribute. You probably didn't add the individual request description here. One of the things that's really cool with modern day, go in and document one method in your controller with the standard that you want to adhere to. Now, we all can take AI with a grain of salt. We may have our own opinions, but AI is really good at repeating processes. What I have found amazing luck with teams is setting a standard and then giving Copilot in agent mode an instruction, such as finish documenting the rest of the API methods in this class using, and give it the method that you want it to use as the example for the standard that you're looking to do. It's not going to be perfect, but you're going to blaze through 90% of the documentation in 30 seconds. And then you can come in and become a proofreader. You can become a documenter. We have used this extensively to go back and clean up projects now and save a whole bunch of time. So don't forget some of those helpful tools that we might have with modern day things like GitHub Copilot, or if you're one of the ones that uses other IDEs and Cursor or whatever you might use. Think about how you might be able to use AI auto-completion, things that know the context. Because what we've learned in our experiences so far is that if I tell it to document a method like this, it is smart enough to find the 3 different return methods here that have 3 different return types and actually set them to an appropriate response type based on what's being tossed out by my application. So definitely a way to kind of help maybe ease that burden for you a little bit. I've even had luck with folks doing this in GitHub, assign a work item and do it in agent mode over there and say, document everything in this project, and been able to do it. We've even used it to implement API versioning as well. So just a way to kind of think outside the box a little bit to potentially bridge that gap along the way. And then this way, everything lives in here. What's also nice when we talk about long-term standards, sure, it's great that this information is available to those that are consuming the API. It's also really good for your developers, your code review processes, and otherwise, that I intended to do this. I intended to have this response behavior. Really helps, 6 months down the road, a year, 2 years, 3 years later, to be able to step back and say, oh yeah, we really did want it to return this for this reason. So definitely valuable things along the way. I think we're going to see some changes in .NET 10 with OpenAPI. I just don't believe that all of them are finalized yet on exactly what that looks like. So hopefully there's been some helpful information here about how to put these pieces together, what the roles of the respective projects are, and how you can, use these in your projects to be able to deliver something great. Open up if anybody has questions. Love to make sure to answer anything else that that you folks may have. So otherwise, really appreciate it. I don't know. Did Sean?
Hey, this is a bit weird, but you say that this handles like 95%. The example you gave where you did one method and then the rest you just did AI and had it handle most of the other stuff. What are do you see any pattern in the fixes that you have to do when you do that? Like,
You know, occasionally, um, one of the we've done it like on, I think I've done it on 4 like really big projects so far. And I would say that yes, one time I didn't like the words it was using. Basically, the project was for a company in an industry that, let's just say that the English didn't work out great when it did its AI thing. And so we actually reprompted it afterwards and said, hey, you did a great job, but we don't like this phraseology. Can you please re-standardize with this into consideration? And it fixed 90% when we saw a pattern on its own. So one of the bits of guidance I've given my teams, if we are using AI for documentation, is don't necessarily go in, if you let it document everything in a class, look at a couple of the methods and see if there's a pattern between the methods before you make your edits. Because if there's a consistency thing that it's doing, or let's just say it's consistently omitting, for example, the produces response type attribute, then you can kind of go back and give a really good guided command back to GitHub, and make it work. And if you're doing it large scale, I'd recommend doing it in agent mode within GitHub itself, solely because when you do it in agent mode in GitHub, with the pricing change that occurred, I think it was partway through last month, any time you go back to it and say, go do this, is only one premium request. So if it goes and sits out there and chugs for a long time, like we had to do API versioning on a project that had 900 endpoints, and we used 2 premium requests, one for it to do it the first time, and then one for it to fix the Swagger docs. And we were done. Something that our offshore team had estimated as 3 weeks worth of work we did with 2 premium requests and about an hour and a half of review. So it is definitely a case where AI can help. But yeah, if you see a consistent problem, a consistent behavior, use that as a prompt to double back and make it fix itself.
okay, thanks.
Yeah, absolutely. All righty. Any other questions or things like that? I know it looks like Sean is here, but doesn't exactly have a great internet connection. I don't know, Sean, if there's any specific message or anything you want me to pass on to folks. Maybe if you just have text if need be, just about future meetings, things like that. Meetup obviously will have all of the future meetings, and everything for folks. If anybody has questions, I know that with this, just like a lot of the things that I talk about, sometimes people don't like to necessarily share things along the way. So what I'll do now is I'll go ahead and stop recording so that anything beyond this point will not be recorded. So that way, if folks want to say or converse about anything that they don't want recorded, you'll be able to do so. So I'll put my contact information back up here, and then I'm going to go ahead and stop recording.